Alrighty guys, welcome to my review of right triangle trig coming up for this test that we're going to have on Tuesday. So I have in front of me the review packet and a calculator. You definitely will need a TI-83 or 84 to complete quite a few of these questions, or really any calculator that's got sine, cosine, tangent, and their inverses as well. Let's start going through them. We're going to go through just a couple questions from each section. So starting off, these first couple problems, all of them are just some basic Pythagorean theorem. There's really not much to it, but let's do it. Let's work through these. I'm going to try number 4 and number 5 because I think they're the more interesting questions. So number 4 and number 5, what you got to realize that this is an isosceles triangle. Both of these guys are the same. Because both of those guys are the same, it must be the case that this guy creates a right angle. We call that an altitude, by the way. The altitude creates that right angle, and it's also a perpendicular bisector. That'll happen for any of these isosceles triangles. So this has got to be a 15, that's got to be a 33, and therefore we have very basic 15 squared plus 33 squared equals x squared, because this is our hypotenuse, that longest side. And just go ahead and use the calculator efficiently to solve this. I'm going to go ahead and switch sides over here. Let's get going on it. So in order to do this on the calculator the most quick, you want to take the square root of both of these guys, or taking the square root of both sides to solve for x. That's going to be 15 squared plus 33 squared. Boom, and this is round to the nearest tenth, so correct answer here is going to be 36.2. Easy enough, not too bad. Try out number 5 here. Number 5 I think is a pretty interesting question because you actually have to do the Pythagorean theorem twice, and you really want to keep track of that as well as possible. But this is a problem where you can actually do a trick. You can recognize that this is a 3, 4, 5 triangle. What am I talking about? Actually, is it a 3, 4, 5 triangle? It's not a 3, 4, 5 triangle. I lied to you guys. I thought it was. I thought this was divisible by 4, this was divisible by 5. I thought it was going to be 3, 4, 5, but it's not, unfortunately. So we're just going to have to solve for it. We have to create another letter. We're going to call that letter y right there. We can say that y squared plus 16 squared equals 25 squared. Going to create that Pythagorean theorem for us. And likewise, just like this question, y is going to be equal to that square root of 25 squared minus 16 squared, going right into that calculator for us. So square root 25 squared minus 16 squared. Now what's important is we actually leave this number in the calculator. We don't want to have any rounding errors anywhere in the question. So we want to make sure that we keep that number in the calculator when we do the next problem, because we know that x squared plus y squared must be 22 squared. And we want to solve for x, so it must be one little step. X is going to be the square root of 22 squared minus y squared. So in the calculator, we're going to do 22 squared minus, and we're going to copy that answer. Boom, put it right there. What I did was I highlighted it, and I hit enter. And that's going to go ahead and put the copied version of it right there for me. So now when I square it, I don't have any rounding error whatsoever, and that's going to be 10.7. Let's do some of these word problems. I'm going to do question number 7 because I think it is the most interesting word problem. And also number 8 because it has some unit conversions for us that we have to deal with. They're not really conversions, but just a thinking process that we have to do. So number 7, it says 2 vertical posts stand side by side. One is 8 feet tall while the other is 17. So we have one guy is 8, the other guy is 17. Okay. And they're both vertical, so in other words, they both create right angles to the ground. All right. One is 8 feet tall, one's 17. 20-foot wire is stretched between the tops, so this guy right here must be 24. How far apart are these posts? So it wants to know what this distance is right here, what this distance is right there. And what we can do is we can do 17 minus 8 to get 9. Call this guy x, and therefore x squared plus 9 squared must be 24 squared. Solving for x exactly the same way we've been doing. Square root 24 squared minus 9 squared. Hit enter on the calculator for us, and we're going to go ahead and get 22 points 22.2 looks like, specifically in feet. Make sure you put units on the questions when they ask for it. Question 8 here, 15.6-inch laptop is featured in a sales ad. This distance is the diagonal distance across the screen. So what it's saying is I'm creating this guy here. We know that this guy right there is 15.6. The screen measures 7.8 inches in height. So this guy right here must be 7.8. And I guess this must be the width. Normally this is the width, this is the length, but whatever. I guess it's just a different kind of question. Same exact idea, nothing new. X squared plus 7.8 squared equals 15.6 squared. So x is going to be equal to that square root of 15.6 squared minus 7.8 squared. Calculator it, square root 15.6 squared minus 7.8 squared. And that's going to give me a nice little 13.5 in this inches. So let's go ahead and be lazy as possible with those inches. Moving on to that second page. So given the side lengths, determine whether the triangle is acute, right, obtuse, or not a triangle. So step 1 in every single one of these questions is going to be immediately check to see if it's a triangle or not. What I'm talking about is you always have to check to see if A plus B is greater than C. That is, the two smaller sides have to be larger than the third side for it to be a triangle. So for instance, number 15, I check immediately. Is 15 plus 17 greater than 21? Sure is. 32 is much bigger than 21. So that's definitely a triangle. Once I've checked if it's a triangle or not, I have to now compare 15 squared plus 17 squared. I don't know if it's bigger or smaller than 21 squared, but I'll use my calculator to help me out. I'm going to do 15 squared plus 17 squared. That's going to be 514. And then 21 squared happens to be 441. And as it turns out, this is bigger than that. When these two sides squared are bigger than the other side squared, we get an acute triangle. This triangle right here, 6 plus 12 is not bigger than 19. 6 plus 12 greater than 19? Question mark? No. So it's not a triangle. All those questions are just like that, so I don't think we need to spend time doing it. Please note, really, just following along the rules. The front page of this packet helps you out to figure out if it's acute, obtuse, or right. All these, we kind of just set it up for you right here. Converse Pythagorean theorem. If they're a squared plus b squared equals c squared, right triangle. C squared's bigger, obtuse triangle. A squared plus b squared bigger, acute triangle. Not much to it. Questions 13 to 18. Really, there should have been better directions on this. No calculator. In fact, on the actual test, it's going to say if you answer in decimal that you basically got these questions wrong. Every single one of these questions, you must redraw the triangles that you found, again, on that front page. So let's look at that front page one more time. We're talking about these two special triangles. They call them cheat right triangles. I don't know why they're cheating triangles, but in this situation, we got to make sure across from the 30 is a 1. That is, across from the 30 is a 1. Across from the 60 is that rad 3. And across from the right angle there, the hypotenuse is the 2. Same thing, across from that hypotenuse is a rad 2 now, with 45 and 45. Across from the 45s are 1s. Got to have those memorized. And now you draw them up. So this first one is actually a freebie, because if I were to draw my triangle correctly, again, I am drawing that triangle from the front page oriented in the same way as the question. We notice that these two sides must be the same, so x is 10 right away. This side over here, all I have to do is multiply this side by rad 2. So if I just do 10 times rad 2, I'm done. That's the whole problem. There's really not much to it. We can follow the same exact logic on any question that is that simple. Unfortunately, not every single question is that simple. Let's look at one that is, though. Number 17 is going to be that simple. So we first draw the triangle oriented in the same way. So I have a 60 degree down here. Across from the 60 is the rad 3. Across from the right angle, the hypotenuse is a 2. Across from the 30 is a 1. if you notice, if I do rad 3 and divide by rad 3, I'll get to 1. So if I take this 11 rad 3 and just divide by rad 3, I'll get to x. So x must be 11. Y must always be 2 times that. Super fast. Let's say you weren't understanding that method. I'm going to do the next 2 questions using a different method. I'm going to use the proportions method. Proportions method I'm going to take for number 14. Again, step 1 is always drawing that triangle right away. So we have the right angle 30, across from the 30 is a 1, across from the 60 is a rad 3, across from the right angle, that hypotenuse is a 2. So again, I think this is an easy one because I would just multiply by rad 3. I would get x must be equivalent to 7 rad 3 just by looking at it. But if I wanted to set up a proportion, I could. I could simply set up that x over 7. I'm doing the left side over the right side must equal the left side over the right side. And cross multiply. 1 times x is x. 7 times rad 3 is 7 rad 3. Easy enough. I could set this up for all these problems. Y over 7. Y over 7, which is the bottom over the right, must be equal to the bottom over the right equals 2 over 1. Cross multiply. Y equals 14. Nice and easy. Number 15. Same exact idea. Not too bad. Not too bad at all. When you get good at these, you can actually just like see it. What am I talking about? Well, we know across from the 30 is the 1. Across from the 30 is the 1. The hypotenuse is always 2 times it. So if I'm going to that x, it's half of the hypotenuse, 16. The other side must be 16 rad 3. But again, I could have set up those proportions. If that is not making sense to you, set up those proportions. So setting up the proportions. Boom, right angle. 60. Across from the 60 is the rad 3. Across from the 30 is the 1. The hypotenuse is a 2. Setting up a proportion, for instance, let's say I wanted to solve for y. Let's just do solving for y because I think it's actually a little bit more difficult with this proportion method, and it might be a little bit more interesting. Y divided by 32 must be equal to, and that's the top over the bottom. The top over the bottom must be rad 3 over 2. Cross multiply to solve. 2y equals 32 rad 3. Divide both sides by 2, and y equals 16 rad 3. Same exact answer, a little bit more work. 16. This is the first one that is actually truly more interesting. Let's actually solve it all the way out. I'm going to use the x method just because. You don't have to use this method, but this is called the x method. This is going to be an x. This is going to be an x. This is an x rad 2. This is your other way of memorizing these triangles, where you simply tack on an x to each one of these guys, tack on an x. Not too hard. So what we're going to do is we're going to say 6, the side that we know, is equal to the side we're looking for. 6 equals x rad 2. Divide both sides by rad 2. 6 rad 2 must be equal to x. The problem is we have an unrationalized denominator. So unrationalizing this denominator, we're actually rationalizing it, sorry. Multiply by rad 2 over rad 2. I'm going to get 6 rad 2 divided by 2. And that's going to be 3 rad 2. And in any of these 45, 45, 90s, these two sides, the legs are the same. Let's see if we can do this next one the quick way. Again, one more time. We have this 45-degree angle down here. Because we have this 45-degree angle down here, it's always this side divided by rad 2. The hypotenuse divided by rad 2 is z. Therefore, z must simply be 24. That also makes this side over here 24. And if that side's 24, it's across from the 60. Whew. Well, if we want to solve for y, that single side, we divide by the square root of 3. 24 divided by the square root of 3. Here's a trick for you. Interesting idea. So, like this 6 divided by rad 2, it's going to be 3 rad 2. If you notice, we simply took that 6, divided it by 2, and added on a rad 2. This 24 divided by rad 3, by the same reason, is going to be 24 divided by 3, which is 8. Add the rad 3 to it. This will work every single time. X is always twice that smaller value, 16 rad 3. So I showed you a lot of different ways for these questions. It doesn't matter which way you solve it. Pick your favorite and stick to it. Next question. Find the indicated trigonometric ratio as a fraction in simplest form. So again, no calculator. Sine of L, very easy. It is just going to be the opposite over the hypotenuse. Remember, you got to have these down, your SOHCAHTOAs. You might want to write that down. The front page has that SOHCAHTOA right here for you. It's got that opposite over hypotenuse. You got to have these memorized. There's nothing else to it. Please make sure you know them. I'm going to talk about it one more time just here in front so you can see it. You can skip this if you feel like you have this mastered. But if here's my theta, the opposite is going across. The adjacent is next to, the hypotenuse is up here. Please note, if my theta was in the opposite side up here, opposite is down here. So here is opposite, here is opposite. It doesn't matter how the triangle is arranged. Opposite is always going across. Adjacent is always right next to. Adjacent, adjacent. And the hypotenuse is, well, it's the longest side across from the right angle. So this guy here, 6 over 10, opposite over hypotenuse, you get 6 over 10, which reduces to 3 over 5. One thing that's actually a thing you can do in a question like this is if you want to avoid reducing these fractions every single time, you can actually just draw the similar triangle immediately. This will always work for sine and cosine, but it won't work for all kinds of questions. Divide both these sides by 2, 3 over 5. You can actually notice if you do this, this is a 3, 4, 5 triangle. You could solve it using Pythagorean theorem. Likewise, this guy must be 8, same exact logic. Either way, tangent of n, n's right here. Opposite, going all the way across, 8 divided by 6, or 4 divided by 3, m, l, n, 4/3. I don't really think I have to explain too much, but cosine of L here, cosine of L is going to be 4 over 5. It's going to be 8 over 10, same exact thing. Sine of n, 8 over 10, 4 over 5. This brings us to an important idea. Remember that cosine is sine of other angle. Just remember that. It's always a sine of the other angle. These guys are always going to be the same. Interesting little idea. Continuing on, basically all these questions are the same. So I'm just going to solve 2 of them because you don't really need too much more than that. Do number 7, arbitrarily. So number 7, I notice that I have a 75, the 17, and the x. I need to set up sine, cosine, or tangent. One of these 3 to solve this question. So I have 75, and I have to ask myself, do I have an opposite, an adjacent, hypotenuse? Which of those 3 do I have? It looks like I have opposite and adjacent. Because I have opposite and adjacent, I need to know my SOHCAHTOA. SOHCAHTOA. So which one has the opposite over adjacent? Tangent does. So we must say that the tangent of 75 degrees is equivalent to the opposite over the adjacent. And solve. Remember my trick to solving these? We're going to flip-flop. Tangent of 75 and x are going to be switching positions there. X is 17 over the tangent of 75. We got to use our calculator here. So finally we're back to using our calculator. Turning it back on. We can actually create a fraction. One of my statistics students taught me this just 2 weeks ago or so. We're going to hit the alpha button. F1. Enter. That is alpha y equals enter. Alpha y equals enter. Creates this fraction for us. You don't need this fraction. I'll show you how to do it without creating the fraction bar in a second. Divided by tangent of 75. Boom. You get 4.5 rounded to the nearest tenth. Looks like 4.6 is actually the correct answer. And I was going to said I was going to show you without the fraction bar if you don't want that. 17 divided by tan of 75 will give you the same exact answer. So no big deal making the fraction bar, but I think it's pretty cool. Let's look for another one that I want to do. I want to do one where x is in the hypotenuse. Do they have that? Do they have an x on the hypotenuse for me? They do. Number 8. So number 8 right here, we're going to go ahead and know that we have a 43. We have the angle right next to it, or the angle is right next to the side. So there's your adjacent. Here's your hypotenuse. Adjacent over hypotenuse is cosine. Cosine of 43 is equal to 31 over x. Same exact idea. Switch the positions. X equals 31 over cosine of 43. Solving it out, again, alpha, F1, enter. We got 31 there. We got cos of 43. And we end up having 42.4. Really not that big a deal. Let's do one last one. Let's go actually go back up to number 5 because I want to make sure people aren't always just dividing because it doesn't happen every time. In this one, I'm going to skip in the setup here, but it's cosine of 32 is equal to x over 14. If you end up with a setup like this, you kind of just whoosh, put that guy up there, and you get 14 times the cosine of 32 equals x. 14 times the cosine of 32, and that's going to give us 11.9. Easy peasy. The next 4 here are all looking for the angle. Whenever you're looking for the angle, you're looking for the angle, use inverse. Every single time you're looking for an angle, use that inverse. Same concept though. I have an opposite and adjacent here, so I know that the tangent of x must be equal to the opposite over the adjacent. And now I use the inverse. X equals the tangent inverse of 9 divided by 12. So we got that tangent inverse. So I hit the blue button, second tangent, to give us that tangent -1 of opposite over adjacent. Get 36.9 there. 36.9 degrees. Not too big a deal. Let's keep on. Let's try to do a word problem here. Kurt spots a bird sitting atop of a 40-foot tall telephone pole. So Kurt, he's over here, he's chilling, and a 40-foot tall telephone pole. And there is our bird. I'm not even going to attempt to draw a bird, but there's a bird right there. Bird. Bird. Okay. And here's Kurt. Okay, here's Kurt. He's just a dot. If the angle of elevation from the ground where he is standing to the pole is 59 degrees, angle of elevation coming from the ground, coming up from the ground is 59 degrees here. How far is Kurt standing away? So we have this right triangle we can create. We are looking for how far away he is. Now, do we really have to solve this? It's the same exact thing as this. Once you draw the picture, it's the same thing. Tangent of 59 is equivalent to 40 over x. Therefore, x equals 40 over tangent of 59. It is the same thing over and over and over again. 40 divided by the tan of 59. Boom. 24.0 feet. Great. Go to the next page. Same exact ideas on all of these. You know, you're basically just working through it best you can and drawing these pictures up. So let's just do this number 14. Helicopter flying 16 feet above the ground. So helicopter is flying. He is 1,600 feet above the ground. And he spots an airplane flying higher. The horizontal distance between the helicopter and the airplane is 3055. And the angle of elevation is 71 degrees. So he is flying up here, 71 degrees. There's my 3055. And it wants the airplane's altitude. It wants this entire length up here, but you're only able to solve for x. So what you can do is you can say the tangent of 71 is equivalent to x over 3055. So let's do it in the calculator. 3055 times the tangent of 71, 8872. Oh my, but don't forget, there's the 1600 you got to add. That's going to be something people are going to forget to do. Got to add that, and we end up with 10,472.4 feet above the ground. Easy peasy. One last one with an angle of depression. A shark is swimming 28 feet below sea level. So a shark is down here. He's below sea level 28. Here's our shark. If the angle of depression from a boat on the water to the shark is 19 degrees. So here's my boat looking down at the shark. Angle of depression is always coming from the horizontal, looking down over here is this 19 degrees. What is the horizontal distance? We are looking for x over here. Again, looks like an opposite over adjacent. the tangent of 19 is equivalent to 28 over x. Switch those positions. We get x is 28 over tangent of 19. One more time in this calculator. Alpha, y equals, enter, creates that fraction for us. 28 over the tangent of 19 degrees. And there you go. 81.3 feet is how far away this guy is from the boat. Look at this. The triangles show up again. I don't know why they're here again on this review packet. I got to be honest. I'm the one who printed this off, so that's kind of my fault for putting that there. But I don't know what I'm doing. More right triangles. Honestly, this is the same stuff as that front page. I don't think I need to do it. But number 10, I'm going to do instead. So number 10, find the perimeter. Remember, perimeter is going to be adding up all these sides. X, 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 X. It's a square. Because it's a square, these are all right angles. Diagonals in a square divide this exactly in half, so that's got to be a 45. And if this is 14 rad 2, same logic as that front page, these must be 14. These are all 14, in fact. 14 times 4, because there are 4 14s. That's going to be a nice little 56 is our perimeter. I'm kind of bummed they don't have any units there, but, you know, whatever. Find the altitude of the equilateral triangle. That's this height right here. We talked about that in the front. Equilateral, these are all 12, and if those are 12, these guys must both be 6. And if it's equilateral triangle, this is a 60, and that's a 90. That makes this a 30. Makes this a 30. So just a little bit of thinking. Across from the 30 is the 1. You know, drawing this triangle out. Across from the 30 is the 1. Across from the 60 out here is the rad 3. Hypotenuse is 2. You notice how that's times 2? Easy enough. This one is times rad 3. 6 rad 3 is the altitude of that triangle. Again, kind of bum no units, but there you have it. Find the missing lengths. Again, there's not much to it. Don't need to waste too much time. Sine, cosine, tangent. We've spent enough time doing that. More stuff solving for opposite over adjacent. More tangent stuff. Do I really need to do any more of these? Let's see. Let's see. Have I taught anything else? Measure of angle A. Oh boy. Man, my printing skills just kind of hurt here. That should have been an A there. That should have been a 12 here. You know, an 8 here. But it's all the same stuff. You know, we are looking for an angle. Looking for an angle. We need to do an inverse. Let's just do one of these just cause. So we can do, for instance, the sine of A must be equivalent to the opposite over the hypotenuse. Therefore, A is equivalent to the sine inverse of 6 over 8. Use that calculator. We got the sine inverse of 6 divided by 8. And we just get a nice little 48. And what do they want? Nearest tenth? 0.6 degrees. Easy peasy. Any more of these? These are just more word problems, same exact thing, same exact thing. I think this video's done, guys. Good luck on this test coming up on Tuesday. I wish you guys luck.